So hello everyone, this is Blindference project and this is our wave 2 submission for the Buildathon. So in the wave 1 what we actually solved is that we were able to give this encrypted inference on both the sides. That is the user side that actually uploads its data on chain and this AI lab side that actually uploads its model weights on chain. Now we have this encrypted inference using FHE and using co-FH accelerators we are able to get a fast encrypted inference there. But the problem is that you can't run these big AI models, these neural networks on-chain, and also the non-linearity problem that are going to come in the FHE computation. So we actually triggers that in this wave 2. We can say that the AI is eating these financial services, for example, this loan decision, fraud scoring, these credit scores. But there is a problem that nobody talks about. To run an AI model on your data, you have to hand it over in plain text. Your credit score, your loan history, your defaults, all readable by whoever runs the model. And Blindference actually fixes that. We let you submit this encrypted financial data to a quorum of AI nodes. They run the model, they commit the result on-chain, and you never expose your inputs. So before explaining how this actually works, let me give you a simple demonstration of what this basically quorum actually means. So before that, you have to run some of the commands to be able to get these complete reproducible results. And again, I have given all these commands in the README file, so you can, if you want to reproduce this, you can. So let me just run these commands first of all. Alright, you can see all the commands are running fine. So I'm going to connect my wallet to here. You can see I'm going to connecting. So this is my 5th account. And why is that? Because I'm going to explain it in a bit second. So I'm going to make a new inference request here. You can see if you have two models here, again their model telemetry available here. All this accuracy based upon this I can choose a model. And this is my private data that I'm going to actually send here. Again, this particular thing can be called by a particular smart contract as well, but for simplicity we're going to use the front end for this particular demonstration. Again, you can also check this hallucination coverage if you wanted. I'm going to run the encrypted inference here. So just for the reference, I'm going to also open my MetaMask extension over here to actually show you what actually happens. So again, we are encrypting these inputs here so that no one actually can see this. So I'm going to confirm this transaction. This basically uploads these private data points to on-chain to an encrypted inference. Again, the transaction was completed. So we're waiting for the grant permission. Now what is grant permission? We're going to do this 3 times because we have 3 one leader and 2 verifiers. I'm going to explain how this actually works, but let's actually see the demonstration first. So as you can see, we are submitting these grants to them so they can actually basically decrypt these values that are actually submitted on chain. Okay, leader node is executing its result and we are waiting for it. So to get a consensus out of it in this quorum, again, all of the 3, this is a leader node and the verifier confirms that whatever the inference is actually correct. So now we are verifying the results. Just wait a bit. So in the meantime, you can see that we have these nodes and models. So what we're actually going to serve here is that we are creating this layer, that coordination layer. Basically, what's going to happen if you want to basically inference or basically use AI agents in the further wave, you can use that and basically going to call our, using a smart contract, you can call our inference coordination layer, and using that we're gonna basically distribute these 2 different nodes that gonna basically give us computation there. Right, so you can see we have risk score 67 and consensus comes 2 out of 2 quorum basically satisfied that whatever this particular leader node gives us is actually confirmed by these verifiers. So what actually happened in the backend? Again, you can also buy coverage if basically your AI LLM basically hallucinated somewhere. So we're gonna compare that to a particular oracle there that again, we have a hallucination there. So we're gonna give you some premium out of it, and you can also file dispute if you think that this leader node actually gave you bad results or basically manipulated the results in some way, right? And also the escrow release, all those things are right now mock here because from the runner side, we actually, those operator things haven't been implemented, so that particular thing actually mock here. But again, we can actually, once we get all the interfaces, then we can actually complete this cycle easily. So what actually happening is we have these 2 things. First of all is this ICL coordination layer that basically gets the inference request, and these 3 things, which is 1, 2, 3, which is 1 is the leader node and second 2 are the verifiers. So what happens when you sends a request to the ICL basically inference coordination layer, it sends it to these 3 different ones, which is the 1 leader node and the 2 verifiers. The leader node runs its encryption And again, we are giving the grants that we actually give the signature out of it. So we are giving the grant to the leader node as well as the verifier. And after the consensus come that again what the leader node is saying is actually correct, we delivers it back to you. Again, we also take some stake from the leader node that he's actually not manipulating the results in some way. And in the further ways, what we're gonna actually explore that we're gonna give this fundamental layer out of it. And what can happen is that people will gonna call our inference coordination layer, and we're gonna use, again, people are also gonna register in this nodes here that gonna serve the computation layer as well. So what can happen, we're gonna basically coordinate these nodes, we're gonna give them permission to be able to decrypt and gonna stake some of the money so that they are not manipulating the results, and people will be able to make different applications out of it. We're gonna give those coordination layer to them. They can run AI agents, they can run different models out of it, because at the end of the day, we just have to verify if all this quorum actually comes to a consensus, and if not, then we're gonna charge some of the money to them, to these nodes, to these models. Yeah, that's pretty much from our side. This is Blindference signing off.